Hey YouTube, I wanted to make a video talking about some of my LS oil pressure issues. If you haven't seen any of my other videos, well, first off, sorry my garage is such a mess. I dumped a whole bunch of coolant all over the floor because that's how I roll. But anyway, if you haven't watched any of my other videos, this is my LS swapped 84 Corvette. I recently pulled that motor that's in the bag, which is my cammed LS6 with an aluminum block, and I swapped in a built LQ9, ported heads, cam, blah, blah, blah. Anyway, so I finally got the tune to the point where I can drive the car and I'm reasonably happy with it, but I started having some oil pressure problems. And I think it was caused by this guy. This was the oil pump. Yes, my lovely workbench here. But anyway, I think this oil pump was my problem. So let's talk about what was happening, and maybe if you're having a similar oil pressure issue, maybe this would shed some light on maybe what you got going on, because LSs are notorious for having oil pressure problems, sometimes even on new engines. And I really hope this will remedy my problem. So here's what was happening. Brand new motor, reasonably. I mean, it was still a junkyard block and crank and all that, but I have brand new cam, main, and rod bearings in a junkyard LQ9. Okay, so flat top pistons, floating, or the Gen 4 rods. The motor came out of a 2004 Cadillac Escalade, so it had the heavier connecting rods in it. And I put ported 799 heads on it. Anyway, so I put all new bearings in the motor while I had it on the engine stand, put new piston rings in it, but I reused the pistons, rods, crank, all that fun stuff, and a new cam, obviously. So what I did is I took an oil pump, specifically this oil pump here in my vise. This came out of a 4.8 out of an express cargo van. I pulled a 4.8 with a 4L80E transmission the one time I was at the junkyard. The transmission that came out of that van is what's in this car right now. It has the 4L80 in it with a shift kit and all that kind of stuff. If you want more information on how to shoehorn a 4L80 into a C4 Corvette, check out my other videos. I talk in depth about how I did that. Anyway, I had the parts laying around, so I had this oil pump off of the 4.8, and it seemed in really good shape. It actually was in better shape than the one that came off of the LQ9, so I decided to use it. And I looked at Headflow Inc.'s YouTube channel where he talked about how to port and shim these pumps. So what I did, I took it apart, I followed his directions, I ported the inside of it, shimmed it and all that. And I installed, I had two shims in here, two little washer shims following his directions. Should have boosted right around 10 PSI or so. Put that pump in. When you have to prime the pump, which I'll show you how to do here in a little bit. But I had to prime the pump, started it up, had 40 some odd PSI when I first fired it up. So I thought, awesome, good to go, right? Engine gets warm, the coolant comes up to temp. It had tapered off down to maybe 34-ish pounds, 32, somewhere in there. And I thought, okay, still good shape, no big deal. And then I got the tune where I wanted it, and intermittently had started it and shut it off and went through a couple heat cycles and things like that on a new motor. Took it down the road, drove it, everything seemed fine. The longer I drove it though, I started to notice as I would come up to a stop sign or a stoplight, my oil pressure was coming lower and lower and lower. Now, originally, what I had thought, this is a oil sender that I had on the motor for my IntelliTronics gauges inside. I thought I had a problem with this sender. But I double checked, this car actually has two senders on it. It has one that is the factory LS oil pressure, and that is tied into my Holley Terminator X that's in the car. And then that one goes to the gauge. I didn't check the one on the Holley touchscreen. I just assumed that gauge was reading low. Because as good of gauges as IntelliTronics are, their sending units aren't great. They use these Chinese sending units with good quality American gauges, and a lot of times their sending units can have problems. People have talked about this from IntelliTronics for years. I love the company, I love their gauges, but their sending units are not great, okay? They never have been. Anyway, that aside, I thought that was the problem. Well, I pull up the Holly, I plug my laptop in and check it, and lo and behold, no, I actually did have low oil pressure. It came down to about 15 pounds at idle. What was interesting about that is when it gets that hot and it came down to 15 PSI, when I would stomp on it, well, not really stomp on it, when I would rev the motor up to, let's say, 4,000 RPM, my oil pressure would go up to 30 and stop. It would not go higher than 30 pounds once it was down that low. So it's like, okay, just so you're aware, you're supposed to have a bare minimum of 10 PSI of oil pressure per every 1,000 RPM. So I was under that at that point. And I was hearing a little bit of lifter tap with brand new LS7 lifters. So that's like, okay, I've got air in my oil system, it's aerating the oil, and I have too low a pressure. I've got something wrong. Now, I would park it, shut it off, let it cool off completely, start it again, and I'd be back up to 45 pounds when I first fired it up. And the whole process would start over again. It's not like I would instantly have no pressure. So this is telling me a couple things. For one, I believe this was the pickup tube that I was using. This pickup tube is out of a C6 Corvette pickup tube, along with that pan and that windage that tray is all C6 Corvette. Okay, and the reason I went C6 Corvette pan is because it gives me the best ground clearance in a C4 Corvette. The Camaro pans actually sit a little too low for these cars, in my opinion, and they sit lower than the cross member, whereas the C6 Corvette pan is actually higher than the cross member. So they are a little bit more expensive. I ran the Camaro pan when I first LS swapped this thing, and yes, it'll work. I prefer the C6 pan. It just works better. It also has some awesome, if you look in here, sorry this is so dirty, has some awesome baffles in there that really help against oil starvation and cornering and things like that. I think it's well worth the money to go with that pan. You do have to notch your cross member a little bit for it, more so than you would the Camaro pan, but that's really not a big deal, not if you have any kind of welding ability whatsoever. Anyway, so I had, as you're probably well aware if you're watching this and you're familiar with LS oil issues, I had the thicker O-ring. Now, some people talk about the colors of O-rings. This is a really good example why not to pay any attention necessarily to the color of the O-ring. This is actually a red O-ring that had blue paint on it. And you can see that the blue paint has come off. So people will talk about, oh, there was a red O-ring in there, or there was a blue or a green or a black or whatever other color. Well, you know what? After they work for a while, whatever coating they put on there just pops off. This O-ring came with this tube. So I know it was the right size. And if you actually mic this is the same as any thicker O-ring. I have a Melling set here. Sorry to be moving you around so much. Sorry to get a wonderful look at my steel-toed sandals there, huh? Oh, I got a couple different springs. I didn't even notice that. Okay, so this is a Melling O-ring set that comes with the Melling pumps, which we'll talk about here in a minute. And you can see in there you get a black and a green. This one that came with the C6 Corvette pickup tube is the same as the green that's in this kit. Okay, so I want to pull this out here because everyone talks about these O-rings, and I was unaware there are actually, if you look at this slip from Melling, 3 different types of pickup tubes that require different O-rings. Most people are familiar with this style. The actual pickup tube right here has a groove in it. That requires a thicker O-ring. You can get away with the green from Melling, that's fine. You can get away with any, I think Felpro uses a red. It doesn't really matter. There's only 2 different sizes of O-rings. If you buy a kit that has both O-rings, just look at them. It's pretty obvious to tell which one's thicker. If you have this groove, it needs the thicker one. Come over to here. This is a straight wall, so this piece here would be straight walled. That requires the thinner, in the case of Melling, the black O-ring. This tube is neither of those. It is this middle where it actually has a bell to it. You probably can't see, maybe you can see there. You can look at the diagram there. Oh, that's metric. Sorry, let me get to the American side here. So you can see this bell here, tapered end, 870 thousandths at the end, 840 thousandths at the inside. So we can take calipers just like this, and we can see that. And this is by far the best way, if you're not sure, the best way to tell which one you have. So if we put that right there, you probably can't see. Comes up to 831. If I put it right there at the very end, you can see 866. So pretty darn close to this 840, 870. So this right here is the one that I have. This tapered end requires the thicker O-ring, just like the groove one does. It does not use the black O-ring like the straight wall does. So if you're not sure, use one of these directions from Melling, and you can see this right here. If you're not sure, just grab a caliper and measure your pickup tube, what goes into the oil pump there, and it'll tell you which one to use. So remember, if it has a groove, use the thicker O-ring. If it has a bell shape to it, also thicker O-ring. If it's a straight wall is going to be 870 thousandths through this whole dimension. Use the thinner black O-ring. Well, in the case of Melling, it's black. I'm not sure about other brands. So I had the correct O-ring in there. I had the thicker O-ring. O-ring was not my problem. Also, I had this piece of garbage. I had this thing, one of these clamp things in there, and you can see it's covered in trash because I just let the thing fly. After installing one of these, it can stay on the damn floor. I don't want it. Yes, they help the pickup tube not walk out. The reason I don't like them, try getting that thing off with the motor still in the car. If you ever have to pull your oil pump and take this off and you've got that stupid clamp with both the bolts up in, you cannot get to that bolt. I had to get real creative with how to get that off of there. It took me an hour and a half just to get that bolt out. That will never go back in. GM didn't design it with that in mind, so I'm not putting it back in. Okay, so what do I think went wrong here? And I still don't know. I still don't have the thing running, as you can see. Well, this was the pump I took out, and like I said, I ported it and I shimmed it. Now, I have taken this apart. I did look down inside, and I don't see anything visibly wrong. But here's what I do think happened. If you think about it, the way these pressure relief valves work, it gave me lots of pressure on startup, but then as the viscosity goes down because the temperature is going up, it's like this pressure relief is not closing all the way. It's not allowing the full pump pressure. It is still bypassing pressure. What I think I did when I ported this, I think that I nicked somewhere inside of this pressure relief that I shouldn't have. I think I cut too much material, and it's bleeding by pressure off this pressure relief somehow. That's the only thing that really makes sense because the O-ring is in good condition and was seated properly. You can see up in here, I still have the oil pan off. Well, you're probably not going to be able to see, but you can see I've got the oil pan off. I looked down through here. I turned the engine over and saw every cam bearing. All my cam bearings are still lined up properly. And if you have a cam bearing that has walked out, you'll typically lose all oil pressure. It won't be one of these situations where you'll have great pressure on startup and then it tapers off like this. That would be something where you would just lose. You'd have crappy oil pressure all the time. I don't have that situation. So what I think's happening is my relief here is malfunctioning for whatever reason. I messed with this pump. I ported it, I ground on it. It was a junkyard pump. Who knows what kind of life it had, even though it looked good inside. I messed with it. I shimmed it. I think this pressure relief is either not sealing properly or it's sticking internally because of me screwing with it. So what did I do? Well, I went and bought a Melling pump. Specifically, I bought this one, 10296. Now, I know what some of you guys are going to say. Well, that's the high pressure, high flow pump. It sure is. Go big or go home. I bought the high pressure, high volume pump. Why, you ask? Well, because I plan on revving this motor consistently to over 7,000 RPM. And that's one fault of the factory LS pumps is they really aren't designed to rev that high. This one is. Yes, it will consume more horsepower. Yes, it will have parasitic loss. No, I don't care. It should give me about at least 10 pounds higher pressure, not at idle, but elsewhere in the RPM range, about 10 PSI more pressure than this pump is capable of. And the oil pressure bypass, I'm hoping anyway on a brand new pump, won't be a problem. I did not take that pump apart to install it. The Melling pump is installed in the car right now. I just don't have the oil pump back on. Okay, I want to talk about that a little bit, because Melling pumps have something little unique going on with them. As you're well aware, if you've ever changed an LS oil pump, the way most people do it is they take these bolts off, they remove the gear out of the pump, and I'm leaking oil all over my floor, and that's an important part of the process. Anyway, you take the bolts out, you remove the gear from the inside, you take the housing, you set the housing on the snout of the motor with the bolts finger tight, and then use feeler gauges to line it up before you torque them down to 18 foot-pounds. You do not do that same process with a Melling pump. Okay? If you do, for one, you won't get the pump apart. Not realistically. Melling doesn't use 10 millimeter bolts like this on their pump. They use Torx that are recessed into the pump. And not only are they torqued incredibly high, they're also red Loctited in place. Removing them, half the time you strip those. I've seen videos where guys literally busted the Torx bits off trying to get them out. Or they just stripped out the Torx bolts themselves. But if you can get it apart, okay, you can do it that way, fine. Melling has a video where they show how to set these pumps and how to align them. What they recommend is slide this on the snout of your crank, put the bolts in finger tight, rotate the engine 360 degrees, then torque them, and you're good to go. No feeler gauges required. Melling says do not use the feeler gauge method with their pumps because you can't take them apart. Some people on the forums had talked about it. Melling claims that if you do take them apart, you void their warranty anyway. So I'm going to take Melling's advice on this. I have never installed an LS oil pump in that way. I have always used the feeler gauge method where you take it apart, set the housing on, use feeler gauges to center it, torque it. But I'm going to take Melling's directions, and that's what I've done. I've bolted them on, I bolted it on, and really what I have left to do is put the pickup tube in and then get the oil pan back on. Now in this particular car, getting the oil pan back on is a pain. This is not a normal application by any means. So the reason that is, just so you're aware, if you're watching this video trying to learn about C4 Corvettes, you can see my cross member. Let me get this light so maybe you can see, I don't know. You can see the front of the motor and where my cross member sits. I have to jack the motor up considerably to get that oil pan to slide in there and bolt down. You just don't have a lot of room right there in the front of that motor, and you can see that's my gasket hanging down there. So what I do, and right now, you're probably not going to be able to see, I have the bolts out of my motor mounts. So it's sitting in the motor mounts, but there's no bolts in there. So what I'll do is I'll put a jack on the actual tabs on the side of the block. I'll put one jack on each side, jack the motor up, or I'll just use a block of wood, one of the two. Jack the motor up as high as I can get it, set wooden blocks under the balancer, take the jacks out, and then that will give me enough room to bolt the oil pan in. Of course, after I get the pickup tube and the windage tray back in, I'll bolt that in and then, take the block of wood out, reverse, everything. Just so you're aware, if you are wondering if the harmonic balancer can come off of an LS motor in an 84 Corvette without pulling the engine, yes, it can. At least with Camaro, the older LS Camaro belt-driven accessories. I don't know about the truck, but I can confidently say if you have Corvette or F-body spacing pulleys, you can remove them without pulling the motor. You can remove that balancer and reinstall it, because I just did it. I did not use an install to put the dampener back on. I used the heat method. I know people are going to bitch, but I don't really care. That's the best way to do it. You take the dampener, put it on an engine, or put it on a jack stand, heat it with a torch until it's hot enough, and then you just slide it on there. It sucks away, that crankshaft sucks away so much heat that it will not damage that seal. And one trick, and this is an awesome trick by the way, and I wish I had a balancer here to show you. I should have taken a video of me doing it. One trick you can do to make sure you're not getting that seal too hot, take a piece of rubber in your hand or a piece of plastic, something that would be similar in material to that seal. And as you're heating it with the torch, occasionally touch it to the metal on the balancer. If you're instantly melting that, you got it too hot. You should be able to take a piece of plastic and lay it on that metal and it not melt that metal. If it instantly melts it, you have it too hot. So you have a test. If you do that, you have to think of silicone baking dishes that go in the oven all the time that can withstand 500 degrees. You are not going to get that balancer to 500 degrees, not even close. You're getting it to right around 250 to 300 at most. Once you take that heat away, it's going to normalize. You're around 300 degrees. You can actually take the balancer for the whole thing in an oven, and that's what I've done before. It's behind that engine over there. I got an old kitchen oven in here. I've thrown them in there at 300 degrees, and they plop fairly well on the shaft too. Now one issue I had on this, I did find that I had a burr on the shaft of this crankshaft that I took a file and just gently removed. Now, I also don't torque them properly either, so people are probably going to lose their minds over that. You're supposed to use a new bolt and torque to yield and all that nonsense. I've done this for years, and I use heat. Never, ever, ever use an old bolt to press the balancer on completely, because when you first thread that bolt in, you only have 2 or 3 threads of engagement. You'll strip the threads right out of the crank. So what you do is you heat it, slide it on as far as you can, at least far enough that you have 9 or 10 threads on that bolt, and then use the bolt to drag it down in. Once it's seated, which will only take at most about 100 to 150 foot-pounds of torque to get it to actually seat all the way onto the motor, take the bolt out, clean it, the factory used old bolt, clean it up, cover it in blue Loctite, tighten it to 200 foot-pounds, not 240, not 250, not 3 million, 200 foot-pounds with some blue Loctite. I've never had one come apart. I've never had one come off. I've never had that fail. I have no issue with that whatsoever. 200 foot-pounds on a used bolt, clean with blue Loctite, works amazing. Or do like most people do, a little bit of blue Loctite. If you have room for an impact, set your impact on high. Give it 3 good whacks with an impact, and you're good there too. But that's going to be, most impacts are going to tighten something down to a little right around that 200 foot-pound mark anyway. If you're talking honestly, most of your half-inch impacts. So what I have left to do, like I said, I'm going to get the windage tray, my pickup tube, my O-ring, and all that back up in. But hopefully, like I said, there's so many different LS oil issues that can happen. I just want to make a quick video showing what I kind of ran into. I ported my pump as an experiment, and initially it seemed to work fine, but I'm having issues where I lose oil pressure over time from driving the car. I really think swapping this pump out is going to fix the issue. One more quick thing. I do want to talk about priming these oil pumps. If you get a new motor and you're putting it together and you want to prime an LS oil system before you rely on it, I hate to say this, fill up your oil filter with oil before you install it. Is it necessary? No, absolutely not. But what it will do is help you show oil pressure on your gauge sooner. That's all that'll do. It'll ease your mind a little bit, a couple seconds sooner, okay? So take your oil filter, fill it up with oil before you install it. Do I do this every time I change my oil? Hell no, it's a waste of time. But in this case, you're watching a gauge trying to see oil pressure for the first time, and you want to make sure you have good oil pressure. Do that to save you some aggravation. Great, okay, fill up your oil filter. Second, you've got a port, and I don't know if you're going to be able to see it under here. Maybe. Okay, so the front of my motor, focus. There we go. So you can see that right there is a port on the side of my motor, and it is on the driver's side front of the block, right there. You can see it looks like a disc that's stuck in the side. That has an Allen head in the side of it. I can't remember what size, maybe 8 or so millimeter. That comes out. That goes straight into your oil galley, going right to the pump. Then what you do is you take a syringe, go to Tractor Supply and buy a big syringe meant for giving medicine to horses. That's what I always use. Take one of those, a little piece of fish tubing, and you're going to put in, I don't know, about 1/3 of a quart of oil, somewhere in there, directly into that pump. You'll know you have enough because it'll start puking back out the hole. Once you've filled it up enough where it's puking back out the hole, you know you have enough in there. Tighten that down, start the motor. No, don't start the motor. Pull your fuel pump relay, pull your coil plugs, whatever you want to do. You're going to crank the motor over with the starter. You should see at least 10 pounds of pressure or so just from the starter. It might take a couple seconds to get there. You know, it might still take 10, 20 seconds to get there, but you should see some kind of pressure out of just from the starter cranking it over. But if you fill up your oil filter and prime that pump first, you really shouldn't be cranking that over for very long at all. And you should see something on a gauge, 5, 10 pounds, something. You see any kind of pressure on the gauge at all, that means that the system is working. At that point, you can plug all your stuff back in, start it for real, and take a look at your pressure. Remember, you only need 10 pounds of pressure per 1,000 RPM. So that means at idle, you really only need, what? Cold idle, you're going to fire up a little over 1,000 RPM. You only absolutely need 15 pounds at idle to avoid engine damage, okay? Now, do you want to, obviously you want more than that, you know, in a street car, but I'm just saying, if you did have a problem or if it takes a couple seconds to come up to pressure, it's not going to hurt anything. You should be just fine. Okay, that's all I got, guys. Like I said, I just wanted to do well, I want to say quick. This is going on almost a half an hour. But I just wanted to talk a little bit about some of the oil issues that I came into and have seen on these. Hopefully my Melling pump fixes my problem. But like I said, I'm fairly convinced that the problem was right here when I ported this pump. I nicked something right here that's allowing that bypass, well, it'd be down in here rather, I'm sorry. I nicked something that's allowing oil to bypass that little plunger in there, and that's what's causing my problem. So, all right, hope you enjoyed the video. Thanks.